So this is problem 20 of chapter 16 of Giancoli 6th edition. So we have two charges. So let me put them here. One charge is at the origin, and the other one is far away, 25 centimeters away in my case. Okay. One charge is larger than the other. So in my case, I have Q1 being positive and 5.3 microcoulombs, while Q2 is smaller and it's negative, is minus 2.9 microcoulombs. I want to know where I can put a third charge so that this third charge will experience no net force. So, by thinking a little bit, you will realize that you can only put this third charge along the line between these two original charge Q1 and Q2. If we try to put anywhere outside, let's try to put here, for example. You can try different options, but what we'll see, suppose this Q3 is positive, okay? So if this Q3 is positive, it will have a repulsive force coming from Q1 and will have an attractive force coming from Q2. So there will always be these angles that will not be able to cancel. There will always be a net force different from zero. Okay, so this is the first thing that if you play with, you will realize that you have to put this Q3 along this line that connects Q1 and Q2. The other thing that you can also realize is that you cannot put in between. So that third charge cannot be here, for example. And why? Well, again, if Q3 is positive, it has repulsive force from Q1 and it has attractive force from Q2, so this can never cancel. It doesn't matter the sign of Q3, positive or negative, you'll find that the two forces coming from Q1 and Q2 have the same direction, so they can never cancel. All right. So, conclusion is we can only have Q3 along this line that connects Q1 and Q2. Now we need to decide if it should be to the left of these charges or to the right of these charges. And then to come up with the answer for this question, we have to think about the magnitude of each one of these charges, Q1 and Q2. See, Q1 is bigger than Q2. So if I try to put Q3 here, the force that Q3 will feel because of Q1 will be much stronger than the force that it will feel from Q2 because Q2 is very far from it. And so let me assume again that Q3 is positive. It will have a big force coming from Q1. So this is the force on 3 by Q1, but it will have a small force coming from 2. So even though they do have opposite directions, so in principle they could cancel, the magnitude is very different, so it will not happen. Okay, so this is not the place to put either. So after all this thinking, you will realize that the only place where you can put Q3 is here, to the right of both charges and on that line that connects these both charges. Okay, because here the force from 2 will be still significant. Let's assume it's attractive. Okay, so it's still significant, and the force from Q1, even though Q1 is so far, since the magnitude of the charge is large, the force is still reasonable, and then it will be able to cancel. Okay, after realizing that, we can then go for the question of the problem, which is where should this third charge be placed? And they want to know the coordinates. So if this line is line x in the x direction, I already know immediately from our initial thinking that in the y direction we do not have anything, so it's 0. So the position is in the x direction. Let's try to find where. So what we want to know, well, this point here is the origin. So this is my x0. This x here is 0.25 meters, and this is the x that we want to find now. What is this one? How we are going to do that? Well, we know that these two forces need to cancel, so the force on 3 by 1 and the force, sorry, this is from 2, now this is the attractive one, and the force on 3 by 1, which is the repulsive one. Okay, so what we need is that the force on 3 by 1 is equal to the force by 2 on 3. So just the magnitude of these forces that's what we are playing with, right? Okay, so caused by 1, we have K, Q3, the value of Q1, and that x that we are after squared. And from 2, we have K, Q3, Q2, and that not really the x that we are after, but x minus 0.25 squared. Do you understand what we did here? What we want is this distance here, right? This whole x. When we are writing the force caused by 1, so this force here, let me put this in red. What we have is that whole distance x showing up here. When we are writing the force here caused by charge 2, what we have is this distance here that matters. Right? So this is why we put here the whole x minus 0.25. And now this is all just a matter of solving it. How are we going to solve this equation? Well, first you can get rid of the k and the q3 and then solve it. Find the x. Now to find the x, the best thing is to do the square root of this equation so you don't play with quadratic equations, okay? So what I'm saying is do the square root of everything you have on the left on the right. So you will be playing with this equation, the square root of q1, which is just a number divided by x, equals to the square root of q2 divided by x minus 0.25. Okay, so we don't have squares anymore. It's much easier to solve this equation than solving the equation on top.